All right. See, okay. Yep. Okay. Thank you guys for attending the presentation here. One of the technical session that we organize weekly, I think. So it's about introduction to GraphQL. It, um, I'm Khairul Ikhwan. I'm from Reporting Foundation team. So basically, I'll talk about the brief summary about the introduction of GraphQL, what it is about, the features of it. So please don't expect too much of the details. I mean, in terms of the advanced level or something, it's just the overview of GraphQL. So in the end of the presentation, you guys should be comfortable of explaining back the GraphQL to your fellow colleagues or something, I hope. Yep. Okay, first of all, let's go through the agenda of the presentation. So I'll talk about what is GraphQL and then the basic features of it. And then, of course, the history, how it's being introduced to our technology. And then I'll talk about the comparison, the GraphQL versus REST API. So you guys must heard a lot about REST API before, and in fact, we are using it here. And then I'll talk about the disadvantages of the GraphQL. And then we are gonna go about getting started of the GraphQL, how we want to implement GraphQL in our solution. Right after that, not to get you guys too bored, I'll present something in the demo and the references of basically the content of my slides, and we go for Q&A session. Okay, so all right, let's go to the introduction. So what is GraphQL? It's actually invented by Lee Byron from Facebook back then in 2012. It's basically because they were having some sort of problems with their news feed. So let's say, for example, if they want to query the news with related to the stories, how many likes or something, they were having problems back then. So they were thinking something to solve the issue. So in 2012, they came up with GraphQL to solve this particular issue. And then right after that, I think, sorry. In 2015, the GraphQL was being open source, so everyone can access it. So you guys can also access through the repository or something. And then in 2018, from Facebook, it's being the project for GraphQL. It's being handled to Linux Foundation. So basically, all those open source right now, it's being monitored by them. And sorry. Okay. So just now I mentioned about data query language, right? So it's basically like the REST API, OData, SOAP, and few other API that we use to get our data from data source, like database or any particular data source. And then it's completely agnostic, as in the sense it's basically independent to any language. So it's just a specification for you to implement how you retrieve your data. So you can use C#, you can use Golang, you can use any other language that you feel comfortable with. And of course, it's open source. You can simply copy paste any code from your repository, or even fork it, just in case if you feel you want to do the pull request into the GraphQL repository. And it's also strongly typed. So it's like C#, where you can define the string integer, ID. So it's unlike JavaScript, right? So it's type safe in a sense that later in our demo as well, I will show the examples for this one. And then it redefines client-server relations. So previously, when we retrieve our data, it's totally dependent on our server of how we send back the data to our client. So after that, I'll give some examples of how the client is totally depending on the server itself, especially for REST. Okay, let's go to the next slide. So this one is basically the GraphQL looks like, in a sense that firstly, the client requests the data of, he wants the album with the name of artist and the name. And then right here you can see, so this one is the request. Just try to focus on this one first. And then the selection set of return is basically the data you want to retrieve from the server. So it's released here with the songs, track number, name, and duration. So the schema is the GraphQL kind of specification for you to return the data from the database or from any other data source. So here you define what kind of information that you want to return back to your client. So we can see here, we can see here it's album and the song. Okay, with the properties of name, release year, artist, songs. There are so many properties here. So if you refer back to the client request, you only request track number, name, and duration. It's very less compared to the one available in the server, right? So that's what GraphQL is about. You can request anything that you want on top of the available resources. So you don't have to query everything. So let's take a quick one on the REST. How do we retrieve the data from the schema here? You would retrieve everything, every single thing, unless you specifically mention your controller or your resolver that you would just want specific properties, right? So here from the schema, I'll show later as well, you can dynamically mention, depending on your request, whether you want track number, or you can even remove track number as well. You just want certain properties. Okay, and then goes to the response there, similar with the what you request. Okay. Don't worry if you don't see the details yet. I'll show in the demo. And then the clients, basically the front end part, they will send a query input to the GraphQL runtime. So after that, there are few flows for that. The query will be resolved by the GraphQL server, and then it will return the data and the JSON result. But it also can be any format of response. So GraphQL API sits in between the clients and the servers. So basically, it will be the kind of middleman for your client to request the data from the servers. So here, just now I mentioned about the data source. So the data source can be actually from, let's say, from SQL server, and it also can be from the REST API itself. Okay, so you can see that it's kind of just the implementation of how we want to improve our architecture or something. So it's not heavily tied or something. So the basic concept here is for you to understand the features of GraphQL and how do you want to implement on top of your existing solutions. So here is the traditional way of REST API. As you can see here, we are familiar with the HTTP verbs, get, post, put, delete. And it goes to the controllers, goes to the models, and then you retrieve the data from database. It's kind of similar with the GraphQL as well over here, just that we only use two verbs, which is get and post. Okay, this one I'll describe later the two the two types that we use to send or to fetch the data or to send the updates to our database. Okay. Okay, for GraphQL features, there are many of them. So on top of the specification, there are queries and mutations. The mutations is basically of the actions that you want to update or delete or even insert into your database. So that's called mutation. Queries is just simply how you want to fetch your data. So here are basically the the features of GraphQL, which you can find in any tutorial website or something. It's basically of how you want to edit your schema, your query, etc. So we are not going through that all of them. So just few of them later, just to get the basic flow of how we want to implement it. And then the schemas and types is basically how you want to design your schema. Okay. And then also in the query itself, basically how you want to specify the way you want to retrieve your data, what kind of field, what kind of action, etc. Okay. GraphQL has the type system, and then like the other language as well, you guys must be familiar with Scala as well. It stores a single value. This one is the one that I described previously. It's we have the strongly typed language, right? So Scala type is basically the ID, the integer, the string. That's the type that we define GraphQL. And then the object is basically like class in C#. It's basically what kind of object can be fetched from database. And then the query is the entry point type to other specific types. So as you can see here, query and mutation is basically the entry point to the GraphQL. So mutation is for data manipulation, which is how we want to insert, delete, or update our data. So you can say it's the match between these two, the query and mutation. And then the enum is of course something that let's say, for example, if you want the user to pick up the options from the list or something, then you would use enum. Okay. Let's go to the Scala type, as mentioned just now. Let's say, for example, the greeting, we want it to define as string. So this is the Scala type, where you find the name of the field with the data type. Okay. And then the object type, it's basically the name of the class here, name of object, sorry. And then underneath the object itself, you can define the field name, the student ID with the ID, first name, age, score. It's basically like C# as well, but you define in SDL, schema definition language. And then for the query type, as mentioned just now, how you want to query from database, right? So here is the example of you define the query. So you need to specifically mention the type is query, and then you want to retrieve greeting with the parameter of string. The mutation here is another type like query, but you want to update your database. So here it's just mentioned add student function, but you can try to just imagine add student is another method to update into database. So here will be resolved from the controller or any function in the back end. But here I'll just put up the add student method. So here you would define the type mutation as well. It cannot be um, mutations or something. It has to be specifically the name has to be specific here if you want to mutate the database. So yep, enum is basically the list here. So list type itself is like an array. If you want to specify an array for the to-dos, then you put up the bracket on top of the field type itself. So for example, if our student ID, we don't want it to be nullable, so we put up exclamation mark, so it can be non-nullable type. Okay, so that's basically the type for the GraphQL. We will proceed with the comparison between the GraphQL and the REST API. So before we go any further, can I have any questions that you might want to ask? No? Okay, cool. All right. Okay, you guys must be familiar with the REST API already. Can I have hands who already get used to REST? Everyone, I think. Cool. All right. So the comparison are way too many, but I'm going to cover some of them. The number of requests, the resources, the URL routes versus the schema, and the handlers versus the resolvers. So here are basically the one that explained just now. Let's say I'll just skip to the REST API example here. Okay. Can you guys see over here? It's okay. So basically here, for those at the back, it's basically the REST API URL for us to retrieve the information. So there are 3 URL over here. It's to get all authors, posts, and the author for the specific person, which is we give the ID over there. So basically this is how we implement in REST API at the moment. Let's say for example, if I want the post for specific author for different ID, for example. So you would need to call different URL to retrieve those data, right? So it will take multiple REST calls to fetch this required data. It will take network usage, and then there are too many things to consider. But of course, you can use cache, but that's another thing to consider. But in GraphQL, you could retrieve all those data through one single call by specifying the authors with the name, post, and get author as well. So it will not only save your time, but we will save so many things in terms of like maintenance, how you want to, and then it also decouple those responsibilities between the client and the server. So the client can predict, it's more predictable. Later I'll show you as well how do we retrieve those schema from the GraphQL. Okay, so basically that's about just now. So to get those posts, comments, and authors, we need to call multiple times. And then for GraphQL, it's just one single call. Okay. Here would be the example of the call, one of the call just now. We specify the ID, and then the response will be in JSON. So here we will get those necessary file, right? Those necessary data. And then if I want more information than that, what I would do in GraphQL will be something like this. You specify the ID as well, but on top of that, you specify the object, which is, sorry if you cannot see. On top of that, we specify another object type in the query itself. So we will retrieve definitely the same information that we want. So it's predictable in a way that you don't overfetch or you don't underfetch. Okay. Yep. Mm-hmm. Mm-hmm. Yep. Mm-hmm. Okay. Yep. True. Okay, sure. I'll talk more about the how the resolver, which is the kind of one of separation for us to handle the query from front end. Okay. Yep. So basically, for those who didn't hear the question just now, Daniel was asking how it's being resolved in a way that we just get everything that we want. So from the query itself, am I correct? Yep. So basically, from the query itself, it will go to the resolver, and then the resolver will check the schema if it match the request here match with the schema that we define in backend, so it will return exactly like here. So it's not just plug and play kind of thing where we just use any library or something. We still need to define our schema, resolver, and sort of stuff. And then the resources for the GraphQL and versus REST. So for the REST, each resource that you identify by URL, you will retrieve exactly the same regardless of your request. So either you send author 13 or author 12 or something for that particular URL, for that particular request, you would get the same response. But for the GraphQL, the description of the resource, it's totally depending on the client. Whether you want more fields or you want less field, it depends up to the request that you made. So here are another example for getting the books with the ID 1. So as mentioned just now, you would get more fields here for the rest. But let's say if your mobile needs just first name compared to the web, because maybe web you need more details. For example, you want to show more details in your web application, but for mobile you only request first name. So here in the request itself, where you call the HTTP GET, you will specify just the title and the first name of the author. Okay, here are basically the comparison just now. I'll just skip it. For the URL routes versus the GraphQL schema, so actually it's the same as well. For REST and GraphQL, both of them we need to call our endpoint. We still need to differentiate whether the API request is basically the read or write. But for GraphQL, if you want to change from the query to mutation, if you want to update something in your data, you just have to change the keyword. While for REST, you'll need to specify, instead of get, you need to call post or something. But of course, there is another way to hijack it. Not hijack, like update or something. You change in the controller to update it instead. Okay. And then, yep, I'll go through the details here. Root handlers versus the resolvers for GraphQL. Okay, just now I mentioned about the schema, resolver, and the query itself. Actually, it's the same as the rest as well. It relies on the framework or the libraries to handle those requests and then to handle the data manipulation and those stuff. But then for the GraphQL, the shape of the response, it's really up. I mean, after you already set up your GraphQL client and the server, it really depends on your request. Why for the rest, all the response is basically the responsibility is back to the server. So you cannot really change the way you want the data from the request. Okay. So in summary, it's not summary, but in comparison between GraphQL or REST, we basically understand that for GraphQL, you just need single endpoint for almost everything. Okay, and then tailored responses, it's like the predictable response from the front end team. Okay, let's say for example, this one would really be beneficial to front end and back end team, for example, because let's say for example, if you want to change something from the back end, and then the front end could still use what kind of the information that you retrieve it. Later I'll show more about this. And then fewer round trips, as in the sense that you don't need to request many times from the endpoint, which makes sense. And then it's backwards compatibility. I'll give some example for REST. Let's say for example, just now we get authors, right? If you want to change to add more fields in REST API, you would need to update the URL. If not, it will break the front end or something because of the new field or something. Because of the new field, and then the URL might be different, but it's different from GraphQL because the front end still requesting the same thing, and then the back end still sending back the same thing. It won't be changed. But of course, unless if you request the same field and then suddenly in the back end that particular field is being removed, then of course it will break all the API that we wrote as well. And then the introspective is basically, it's more predictable. The schema for the GraphQL, it's more informative. And then from the demo letter, I'll show you how we can retrieve the schema of the GraphQL. Okay, so introspective, as in the sense that from the client side, we would know what kind of information that we can get from the server without having to look into the backend at all. So, yep, it's kind of the same point. So I'll just skip it and then go to the disadvantages of the GraphQL. So just now we talked more into the benefits of GraphQL compared to REST API. And then, okay, for the comparison, is there any question? Cool. All right. I'll go to the disadvantages of the GraphQL. So it's the data query language. We can implement anywhere. It's agnostic. We can use any kind of language or something as long as we meet the specification. But that goes to the first disadvantage, the query complexity. Okay, so what you see just now is just the basic the query of getting the authors, let's say for example, right? But let's say from that particular author, okay, I should show in the demo as well later, but this one is just a brief description about the complexity. It can go nested query as well. inside the get author, you want to retrieve more get authors or something, you can send that from the client. You can even send 100 get clients inside the same query. So you would retrieve so many data from database, unless you unless you specifically handle it from the back end of how the query length or something, then it would cause so many problems to the server, the performance bottlenecks whatsoever. And then the rate limiting is basically for, let's say for example, for REST API, if we want to limit the request from the server, from the client, let's say for example 100 requests per day, we can do that because it's basically the same request. But for GraphQL, you wouldn't know the particular query from the client is basically too big or too small. You should, I mean, you could limit the request as well, but it doesn't make sense. Let's say for example, if you just want to request author with the name compared to the author with the whole content, for example, it's not really comparable, as in the sense that if you limit the author just for 10 calls per day versus the 10 calls for the author with the whole content of their posts, their likes, and whatsoever. But of course, there are ways to handle the rate limiting here. How we justify which one is more complicated. Of course, from the request itself, we can check whether the query is too big, it has too many nested queries. Okay, but it's we put up as disadvantage here because without handling those things, it's kind of gonna be downfall to your application. And then the catching part. Just now we call the get author just let's say for example for REST, we just call get authors /1 for the ID. Then we're gonna catch that by identifying that particular URL as the same kind of request, right? But for GraphQL, it's gonna be different for each time, because let's say for example just now I'm mentioning that we're gonna get the author just for name, for example. Let's say for the next time with the name and the birth date, for example. Okay, so it's hard to catch in the sense that the query from the client gonna be different all over the time. But the way how it is, it's always a solution for that. But I'm not gonna cover on that. Okay. So to get started of the GraphQL, it's basically just the language like a data query language. So to start off it, you need to have the GraphQL server and the client. And then for the server-side component, we need to have the schema, query, and the resolver. So the schema is basically just now in the early presentations, I show you the specification of the data available in the server. The query is the request from the client, and then the resolver is basically what we want to resolve the query and then to retrieve the data from the server, but and to match with the schema as well. So the resolver is the one that responsible to validate the request from the query and then to return back to the client. And then for the client side component, this one is just it's not the component based, but it's the frameworks that we can use, GraphQL and Apollo client. And then we'll go to the architecture here. So here you have the Apollo, which is one of the organization that created the GraphQL client and the server. It sits in between of those front end and the back end. So here the back end, as mentioned just now, you can even add up your GraphQL on top of the REST API. You can have the data source from the microservice and of course the database. and then the client itself you would call from the web and the mobile. Okay, I'll go to the demo. So is there any questions so far for? Yeah. Okay. Okay. Mm, honestly, I'm not familiar with OData, but what I could say is OData is actually more flexible compared to GraphQL. For GraphQL, you will need to handle filtering, cache, and so many things all by yourself. There are, of course, frameworks, libraries developed on top of that, but compared to OData, it's already there for filtering, paging, something like that. So in the functionality wise, I'd say it's kind of similar because we can define of what we want is like OData. Yeah. Okay. One is probably what I could think of because GraphQL is open source, and then the community, it's quite vibrant, as in the sense that it's been supported back then by Facebook. I mean, it's developed by Facebook. So I wouldn't say that we should use GraphQL, totally use GraphQL, but I'd say that we can compare the disadvantage and advantage. I mean the features between GraphQL and OData to use into our solution. Yep. Does that answer your question? Partially. Okay. All right. Okay. Shall I proceed to the demo? Okay. Okay. A little bit technical here, but I'll show the local database here. We have guest table, reservations, and rooms. Okay. So basically, it's just a simple data. So you can, from these three tables, we can already assume what kind of relationship they have. So for each reservation, you would have rooms. For each room, you would have the specific guest. Okay, so it's just a simple column here. They have the name of the guest, and then the check-in and the check-out date. And then here the name of the room, and as you can see, oops. Okay, all right, my bad. So the name of the room and the status here is basically just whether it's available or not. And then another column is allowed smoking, which this one I'll be showing in the demo now. So this demo is developed in ASP.NET Core. So basically I just use the existing GraphQL server. And then here, as you can see here, we name our query is test query 2. And what I want to retrieve is basically the reservations. Okay. Then underneath the reservations, I want to retrieve the check-in and check-out date, the guest with the ID and name, and the room tied to the reservations. So you guys can already see the relationship from the table just now. So it's just to show from the GraphQL request. So here, as you can see here, the response is the same as what we request over here. There is no less field or more field other than what we requested. Okay, this one is the default. So let's say, for example, if I want to remove it, the checkout date, I can just simply remove it from the query, and I won't get the checkout date from the request. From the response. And then we try for the parameter. So in the room itself has the column of is allowed smoking, right? So here I put up the room allowed smoking equals to false. So we only get ID 1 for the reservations. Yep. And then if I put into true, if I change the request to true, then I will not get this this room. Okay, so it will be black room because black room is allowing the smoking. And then for variables, we can actually use variable here when we send a request. So it's basically the same as just now, except that we define outside of our request. Okay, and then the filter is here is basically the same. And I'll go through the fragment. So fragment here is one of the feature in GraphQL where you can split up your portion of the query and then group it. So here you can see reservation fields is being shared by two queries here. So here you can define what you want here, and then it's being shared by these two. So it will be the same here. So this one is one of the way to write it more clean code. And then aliases is basically the way to change the field name. So here the field name is the name, right? The one that returned from the server, but I want to return to front end as the guest name instead. So probably the front end team requires it to be this one instead, depending on the situation. So I can just change it to guest name. So here in the response, you would see the guest name would be written instead of the name. So it's kind of flexible in a way. And then here, if you notice, I just send overname schema and types with the name here. This one is basically the sample query that I mentioned about the introspective. So the GraphQL supports the schema query here, and then it will return all those available type for this particular schema. So you can have guest type, reservation query, room type, and room status. Okay, so to answer about the question how they want to resolve our query, right? This one, as mentioned just now as well, will be resolved by the resolver, but resolver will depend on the schema to know whether the query, the request is correct or not. So in the playground here, you can see the schema for this particular server, for data source, sorry. So the guest type having the ID, name, register date, and then here is basically what kind of request that it will accept. So I just now I mentioned that I can just request check-in date because it's one of the available options. Okay, same goes to the room status. Okay. Okay, if you guys notice, the type here is query. So this one is just solely on fetching the data. So I'm not going to cover the mutation, which we want to update our database. So actually, mutation is just simply changing the type here from the query to mutation, and then we need to specify some of the function to update in our resolver. So this one, I'll show the resolver. So the resolver here is quite simple, where you just specify the query here. So on top of that, if you want to specify the mutation to be available, sorry, when I opened the schema just now, I just closed pretty quick, but in the schema it mentions that only query is available. So if you want to enable the mutation in your GraphQL, you can just simply include it here. But of course, the resolver here, it needs to be the function available to update back to your data source. So it's not just that you specify the mutation and then that's it. You will still need a function to handle the query, and then how do you handle those query to update back. Oops. Okay. Any questions so far for the demo? Nope. You mean to resolve the query? Okay. When resolving the query, actually it's taking all the query string, and then it will do some validations in the resolver. I think it's in this one. So for this particular demo, it's using entity frameworks just for the sake of having it fast set up. So here you can see after receiving the context, which is the get query, receive the query. Here you would define all those required things that you want to check. So it's basically the same as REST API as well. So that's why it's mentioned just now. GraphQL can sit on top of REST API. So REST API will be using the similar function here, but here we already handle those complexity and resolve it within one go. So within one query. So you can see that, let's say for example for REST API, instead of getting this one by one, it's getting, for GraphQL it's getting everything in one go. So there's nothing magical here. It's just the way how they specify the query back then. Okay. So here is the one using the GraphQL. So sidecar, instead of just now I put up on left side, I put it in the middle just to make it obvious. So we are using sidecar. We are using GraphQL, but actually I'm not pretty sure which team using it, because my team is Horizon. Yeah, because Reporting Foundation is not using it yet. And then we can see Facebook obviously, and then GitHub, Spotify, Pinterest, and so many more. So what I would say is this one, the list will grow because of the community or something, but then in terms of the practicality, it really depends on your current solution. There are too many things to consider before you start using the technology here. It's similar of WebAssembly as well. If you guys heard about it, they said WebAssembly will replace JavaScript, but it's The trending is not there yet. Okay. And then we go to the alternative of GraphQL. Just now mentioned about the OData as well. So we can use REST, SOAP, and so many more. So Falco by Netflix is basically because by the time GraphQL was created, Falco was created as well. So that's why they stick on it. It's not that famous because, yeah, it's Netflix. And then remote procedure call, for example, for gRPC, which is made by Google. And then here are the references. There are many more, but I'll update the slides later before sending out. So I guess we go to Q&A session. If you guys have any.
Let's have one question. He calling some function for the chain calling, am I right? He called the function one that got the function conditions or whatever filter that they created.
Okay.
That one is reducing the database call too, or it doesn't help us with that one. So each functions which is called to retrieve the few parameters is calling the actual database and fetching the data, or it just create the query dynamically and execute it only once. What does at the back end the resolvers actually works?
The query itself?
Yeah.
Okay. Maybe I'll just open up the resolver again.
Okay.
Alright. So So what I would understand just now from your question, you're basically asking whether the query itself is being resolved by the other class, and it's being
At the line of 87, we're returning the
mm-hmm.
reservation repository, get the query, and put the where to close in that one. So if we call the function two times, for example,
Mm-hmm.
give me the albums and give me the artist name. Two times of calling that function. It first
Understood.
comes here, get from the database, and from the what he resolved, next time he will pick up that, or any times it comes to the server, goes to the database, pick and only filter and return you the data that you requested.
Okay, understood.
Yeah.
For this case, from your particular question, the answer is they will go multiple times to the database.
Okay.
Because we don't implement the caching here. And then the particular caching, we need to know what kind of specific request before we do the catch.
Okay, so
Yep.
he should handle that.
We should handle that.
He should, okay.
Yep.
Behind the scene, it's still actually going back to the database multiple times.
Yes.
And then we just like reassemble the result to return it one time.
Yes. Just that but we save time for the request between the client and the server. Yep.
Yeah.
We just call one time and then the server will do all those magics. Kind of.
Okay, yeah. Thank you.
Any questions? Errors? Okay. GraphQL would just return 200 every time. It will return every single request that you send back to the GraphQL. You will get the success message. Yeah. So I'll just open up the yeah. Yeah, that's one of the things that we need to handle. But it does return something. Let me show the playground again. So this one is the default one, right? So let's say, for example, if I simply put, yep, which does not exist in the schema. Yep. But this one is just solely because from the GraphQL server, it already handled the invalid query. After all, you still need to handle yourself. So if you go I hope I can check from the developer tools just to show the response status. So so you can see it all 200. Sorry. Yeah, the suggested this one. This one is being handled by the Graph QL server. So it's kind of the existing libraries that I use in SP.NET Core. Yeah. So I don't need to handle it myself. But let's say, for example, if you want to develop the GraphQL in Node.js with Express framework, for example, then you will need to handle this. So because it's already existing for .NET Core, I just simply use it, but I don't need to handle it. But because it's agnostic, so you will need to handle it if you use the other language. Yeah. It goes to the resolver as well. So just now in the resolver code, there's a way to for you to get the context, the user context. So it's kind of the same as the REST API as well. Yep. Because after all this is just the client part. You cannot handle the authorization from front end. I'm not sure. But then yes. Yep. Mm. Understood. So yeah. Yep. So let's say if you don't want to use GraphQL server or sample, if you want to use Node.js, maybe you can send implement the authentication from there using JWT or something. Mm, in terms of benchmarking or something, right? Because for REST API, for let's say for example for this particular case, and we can say that it's very high performance in the sense because you don't need to request too many times to the server because that for GraphQL, but for REST API you will need to send so many times for the same request that you need. Okay, yeah, but because this one is not entirely true in many situations because sometimes GraphQL may need more CPU. It's more resource hungry, as in the sense that, for example, just now when I mentioned there are too many nested queries, client can send it. So that's how your resolver is responsible to handle those situations. Um, like one-to-one comparison. Mm-hmm. Okay, you mean in terms of performance? Um, I think we can try that now, if you guys okay. Here, actually, there are particular options to send from old school REST API. It's basically just sending to the controller without any query. So I think we can try to see from here. Just sure. So no, it's not. Mm. Yeah. For example, if I have a front end page, I have a component that only want your avatar, your icon, right? And I have another page that shows your entire profile. Do I build two APIs, one just to return an icon and one to return your profile? Or do I just build one API and both call the same API, but then I only want your icon? Why are you returning me all your address, your phone number, everything? So the GraphQL is to solve this issue, not performance. Okay. I'm not really good at looking at the network performance over here, but we can see the list over here. It's been transferred within 2 seconds. So we can try to compare with GraphQL. 348. Yep. But you guys can compare why it's different, why it's not. So it really depends on the situation, whether when you want to use REST API, when you want to use GraphQL. So it's not entirely a strict topic that GraphQL is better than REST. Okay. Any further questions?
One thing to actually answer the old data one, essentially given old data you're exposing the model. So from the model you change the expand options, everything at the link. Then you will later translate to SQL automatically. But in here, because the old data is actually, you can see the resolver, you are actually writing how to resolve from the bodies and then coming to how do you resolve and then results. So there is some difference in the sense that how do you expose the request being processed. That's the only difference that we have.
Yep. Finish. Mm. The render. You mean, sorry? You mean the resolver? Yeah. Resolver is updated depending on your the whole application itself, because it's not only resolve your schema as well, but it can do the authorization, it can do the caching. So resolver, I think, for in my opinion, would be updated regularly, but schema is not, because it's highly unlikely that you update your data source or something unless you need to. But for, of course, for Psycho, maybe so it's kind of special situation because we do update regularly. Mm. Yep. Yes, I would say the answer would be yes. We don't need to update any resolver or the schema. So it really up to the client for now to request as many as they want, different kind of information that they need. So just now I showed the schema as well. So the client actually can refer to that to request. It's like the playground is actually the API Explorer like Swagger. You guys should be familiar with the API Explorer, the Swagger as well. So from the schema, the client itself doesn't have to go deep down into the class reference or something. Okay. Any further questions before we wrap up the session? Nope. Okay. All right. I guess that's it. Thank you very much, and I'll send the updated slides later with the URL. And sorry for any inconvenience or any how do I put in words? Yeah. Thank you very much for attending.